Chapter 4, Task 4, Finding Solutions by Elimination. First, let's start by reviewing. We're going to identify the opposite of each of the following terms. The opposite of a positive 8 is a negative 8. The opposite of a negative 10 is a positive 10. Opposite of a positive y is a negative y. The opposite of a positive 3x is a negative 3x. And the opposite of a negative 34a is a positive 34a. Notice you can put a plus sign there as well when we're talking about positives. This will be helpful as we go through this section. When using the elimination method, we add the two equations in the system together. Our goal is to eliminate one of the variables. Then we're able to solve for each variable separately. So just like in most methods, there are steps. So we're going to go through the 6 steps of solving by elimination. Step 1, make sure like terms are lined up. Second step, decide which variable you want to eliminate. If you don't have opposite variables, you will need to force the variable to match. And we're going to do some examples on the back of this page 3 and 4 where we actually have to force the variables to match. Step 3, you're going to add the equations. Step 4, you're going to solve for the remaining variable. In step 5, you will substitute your answer into one of the original equations and solve for the other variable. And step 6, you'll write your answers from step 4 and 5 as an ordered pair. So basically, we're solving for x, and once we get that answer, we're going to put it in the first part of the coordinate pair because that's where x's go. And after we solve for y, we'll put that answer as our second coordinate pair because that's where y's go. And then it's always important to check your solution. And we'll do one example where we check. So let's start by our first 2 examples. And please note on a couple of these examples, I made a few errors, of course. So if you don't mind, please write now in your notes, take off this 2. This should have read y plus 3x equals negative 2. So if you'll take care of that right now, it'll make better sense. Thank you. Okay, so the first step, again, was to make sure the like terms are lined up. Like terms, we're talking about the x's and the y's. So we have a y on top and we have a 2y on bottom. Those y's are lined up. Then we're adding and subtracting something in each equation. On the top, they're adding a 3x. The bottom, they're subtracting a 3x. So yes, our like terms are lined up. Over here, our constants, which are -2 and 14, they don't have an x and y, so they are lined up. So we are good to go to step 2. Step 2 says decide which variable you want to eliminate. It says if you don't have opposite variables, we can stop there because we do have opposite variables. What I want you to notice about this system of equations is that the y and 2y, they are not opposites. But the positive 3x and the negative 3x, they are. And this makes our life a lot easier because we can go ahead and draw an old-fashioned line like you learned back in the elementary days where we add the problem together. We can always cancel out opposite terms. Y and 2y are not opposite, but positive 3x and negative 3x are. So we're going to go ahead and cancel them out. I'm just going to slash them. That's good because we got rid of all of our x's. Now we're on step 3. We're going to add the equations. So we're going to add a y plus 2y. Remember, if there's nothing in front of the variable, it's like an imaginary 1. So we're simply adding 1 plus 2, which we know is 3. And we're going to bring down the y with it. Our x's are gone, so we're completely ignoring them. We're going to bring down the equal sign, and we're going to add the -2 and the 14 together, and we get 12. Now we're able to solve because we're only looking at one variable. So this is just a one-step equation. Divide both sides by 3, and we know y equals 4. So we have solved for half of our ordered pair here. So I'm just going to go ahead and set him up here just to show you what our end result will look like. Since y is 4, I'm going to put it right there. Now we have to go and find the x. So we are on step 4. It says to solve, I'm sorry, we're on step 5. We're going to substitute that answer we just found into one of the original equations and solve for the other. In this case, the other is the x. It is purely your choice. We go up to the original equations that were typed, and the first one said y plus 3x equals -2. The second one was 2y minus 3x equals 14. Well, I like to do what's easier or easiest. So it looks to me that the y is all by itself in number 1. So I'm just going to go ahead and plug the 4 in for y there. So I'm just going to show you how I leave myself a space. Get my stylus to work here. I'm going to rewrite the first equation, but I'm leaving a space for that y. So it's blank plus 3x equals -2. Notice, it's exactly the first equation. I just left a space for the y because I'm going to plug my answer in right there. I'm going to put a 4. So what this reads is 4 plus 3x equals -2. Well, I have a two-step equation. So I'm going to subtract 4 from both sides. That cancels. Bring down my 3x. -2 take away -4 is -6. Down to one step. Looks pretty familiar. X equals -2. I'm going to plug this answer in for my x. And this is our final answer. You can always check your solution by plugging the -2. And you don't have to write this. I just want you to watch what I'm doing here. That was going the wrong direction. We're going to plug the -2 in for the x, which in this case is here, and the positive 4 in for the y. So watch what happens when we do that. It would give us, instead of writing y, I'm going to write 4 plus 3 times the x, which is -2, and all of that together should equal -2. And as you can see, my math checks out. -2 does equal -2. So yes, this is a solution. So if you want to go back and check your solution, it's always a good habit. And that's how you do that. All right, let's get to example number 2. I'm just going to draw this line to separate the two. And I made a mistake again for this example. I'd like for you right now to make that a big minus sign. And the reason we're doing that is because on the front page, I have already provided examples with you with opposite terms. So if you made that a minus sign, you will notice the variables are lined up or like terms are lined up, and we have an opposite pair here, which are our y values. We have a positive 4 and a -4y. So those guys will slash or cancel, and we're going to add everything else. We have a 3 plus a -2, which is the same as 3 take away 2, which just leaves us with an x, equals 18 plus 8 gives us 26. So this one was nice and clean, meaning that our x is done for us after just the very first step. So I'm just going to plug him in. So now, again, we can go back and substitute our answer into either of the original equations. I'm just going to, in this case, start with the first one because I don't see any negatives, and to me that looks easier, but again, you can do either one you want. So I'm going to rewrite the first equation, but I'm going to leave a space. I have a hard time with my marker here. But I'm going to leave a space for the x. I have 3x plus 4y equals 18. I'm going to plug that answer in for x. That way, I only am dealing with one variable. So let's go ahead and solve this. That says 3 times 26, which is 78. Bring down everything else I haven't used. Now we're at a two-step equation. Bring the 78 to the other side by subtracting. And I'm left with 4y equals -60. Divide both sides. And we just found our y, because negative 60 divided by 4 is negative 15. Plug that answer into your coordinate pair, and 26 and negative 15 are our final answer. Some systems of equations cannot be solved simply by adding or subtracting the equations. One or both equations must first be multiplied by a number before the system can be solved by elimination. So for those cases, we need to force the variable, what I was referring to in the beginning, to match by multiplying the other coefficient, which is the number in front of x. So let's first of all fix my examples on your own paper if they're not already fixed. My apologies. This, for number 3, let's go ahead and fix the second equation. It should say negative y plus 3. This should be an x equals 2. And on number 4, let's go ahead and set him up also. I think we should just cross this guy out. It'd be easier. It should read 6x minus 7y equals negative 20. All right, so now that we're ready to go, the first step is to line up the like terms, and we have done that. We have our y's set first for us, our x's second, and our constants third. However, I noticed that there are no opposites, so we're going to have to force the variables to match. Again, there are lots of choices in which one you want to force. You could either force the y's to match or the x's to match. In this case, I'm just going to force the y's because that's what comes first. And I noticed that I could easily make a 2y match a negative, or the opposite of 2y. I could force the negative y to become a negative 2y just by multiplying everything in that row by a 2. So watch what happens. Multiply everything in that row by 2. 2 times negative 2y becomes negative 2y. 2 times 3x becomes positive 6x. 2 times 2 becomes 4. So essentially, I just rewrote this whole second line by multiplying everything by negative 2. I'm going to just rewrite my first line so I can match them up again. So I'm just going to bring this guy down here. And just as it is, it originally said 2y plus x equals 3. Now I have a clean system of equations that I can eliminate because they're all lined up perfectly. My negative 2y and positive 2y are opposites, so I'm going to go ahead and cancel them. Remember, we're adding. So 6x plus a 1x is 7x, and a 4 plus 3 is 7. One stepper, x equals 1. So I've just found part of my system. Remember, the x comes first, and I'm going to leave a spot for my y. So now I'm going to substitute in what I just found. I found the x into either of the equations. Again, do what looks easier for you. The first original equation looks easiest for me because x is all by itself. So I'm going to choose the first equation. I'm going to rewrite everything except for the spot for the x. I'm going to leave a space. I'm going to go back up to my answer, which x was 1, so I'm plugging that guy in. Rewrite 2y plus 1 equals 3. It's a two-stepper. Take 1 to the other side by subtraction. I'm left with 2y equals 2. And when I divide both sides, I get y equals 1. So our solution for this set of equations is 1 and 1. Let's go on to number 4 and the last equation. Change my colors up here. So again, you have crossed off the second set if it was not already written like this for you on your worksheet. Sorry about that. So we have 4x plus 5y equals 6, and a 6x minus 7y equals negative 20. Yikes, that's pretty ugly. I think for this case, I'm going to change my x's. So watch what happens here. I can't change a 4 into a 6 or a 6 into a 4 without multiplying each set by something. Well, I'm just going to multiply them by each other. So watch what happens here. We're going to multiply everything, my pen to work, everything in this row